Okay, today we're going to start talking about the idea of polynomial functions and some of the pieces of it. We're going to split this over 2 days. So the very first part of polynomial functions that we're going to talk about is the idea of a degree and the leading coefficient. We talked about degree a little bit earlier in this chapter. Leading coefficient might be a new concept. We're also going to evaluate polynomial functions, as in use the idea of f of x. Okay, to get started, just a reminder that the degree and the leading coefficient of a polynomial we are only going to do when the polynomial is in one variable. So I'm just going to do a quick comparison of one variable versus not one variable. So a polynomial in one variable is kind of like what it says. There's only one variable and that's an x, or an n, or a y, or a z, or an a, whatever the situation may be. If we look at this polynomial, all the terms only have an x. Whereas a polynomial that's not in one variable has more than one letter, an x and a y, an a and a b, so on and so forth. Okay? So, now that we have a polynomial in one variable, if we talk about the degree of a polynomial, the degree, just as a reminder, is always the highest exponent. In this case, our degree is a 5, since 5 is the biggest exponent that we see. The leading coefficient is the coefficient of that term, and in this case, that'd be an 8. Now, do not confuse yourself by thinking that the leading coefficient is always going to be the first term. That's not always going to be the case. And I'm going to use an example right now to show that. Here we have a 4x squared minus a 6x cubed plus x minus 9. 3 is the biggest exponent that I see, so therefore the degree is 3. The leading coefficient is not a 4, but it's a negative 6. The reason it's a negative 6 is negative 6 is the coefficient of the term that has the x cubed, which we said was our degree. Another example, just to show you, is x plus 12. Again, most people confuse themselves with this and think that the degree is 0. But the degree is actually a 1 because this is an x to the first power. The leading coefficient is also a 1 since it's a 1x. So again, just throw out another example that could be a little confusing, and hopefully I've cleared that up for you. Alright, next we're going to talk about the idea of evaluating polynomial functions. When they say find f of 3 for f of x equal to a negative x squared plus 2x minus 3, simply all they're asking you to do is to substitute 3 in for x. So when they say find f of 3, notice all I did was replace each of the x's with a 3. From there, it comes down to understanding the idea of order of operations. A big hint for you here, whether the variables are positive or negative, but get in the habit of using parentheses. So, I put parentheses around my 3 when I substituted in both of the two x's. From there, order of operations say to square, so I am going to square the 3 and get a 9. And since the negative is not inside of the parentheses, it's on the outside, I have a negative 1 multiplying by a 9 to get a negative 9. 2 times 3 is 6, and then minus 3, and then I just simplify that to get a negative 6. So this is my final answer. F of 3 is equal to negative 6. And, just a reminder that f of x is the same thing as y. So what this is basically saying is that when x is 3, my y value is negative 6. So I could write this as a point, 3 comma negative 6. So final solution, f of 3 equal to negative 6. Alright, let's take a look at an example in which we are substituting with another variable. In this case, negative 2a. If I have p of x equal to 4x squared minus 3, I am going to replace the x with a negative 2a. And this is what it would look like. I am going to follow the order of operations by squaring first and getting a 4a squared. I just simply distributed the square to get a 4 and an a squared. From there, order of operations say to multiply, so I multiply and I get a 16a squared, and then I have that minus 3. If I could, I would combine like terms, but in this case there are no like terms to combine, so I'm done. P of negative 2a is equal to 16a squared minus 3. Okay, I'm going to take a look at another example. In this case, I am going to be substituting with a binomial. So, r of x is equal to x squared plus 1. When I substitute, r of x plus 2 is equal to an x plus 2 quantity squared plus 1. Reminder that I cannot simply distribute the square. I must treat this as an x plus 2 times an x plus 2, and from there, FOIL. Okay, so when I FOIL, I should end up with an x squared plus 4x plus 4. Since I do have like terms in this case, I can add the 4 and the 1 together and get an x squared plus 4x plus 5. So my final answer, r of x plus 2 is equal to an x squared plus 4x plus 5. Okay? Alright, at this point, what I'd like you to do is to go back into Schoology, go back into Chapter 6, and I'm showing you what to do here. Click on the folder that says Quizzes, and I would like you to take the 6-3 quiz, and when you're done, submit the answers.